Real estate investment practice problem using Excel. Adjustable rate mortgage or ARMs, no caps, part number 2. Get ready because we're raising the stakes with real estate. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we have 3 tabs on down below: example, practice, and blank. Let's take a look at them now, starting off with the example tab, in essence being an answer key. Last time we looked at the fixed rate mortgage, putting together our amortization table with it to compare and contrast with the adjustable rate or ARM. Then we started putting together the adjustable rate information, taking a look at the index information, and then the rate information that would be used to calculate the loan based on the index, then starting our payments. Now, as we look at our payments, we then need to see what the ending balances will be to see the payments that will be changing over time. That's where we stopped now. We can do that 2 ways. One way is with a formula. The second way is that we can basically construct the amortization table as we go. We're going to actually do it the second way first, constructing the amortization table, this being, I believe, in a more intuitive way to look at this and get an understanding for it. Then we'll go back and look at the balances, which could be a little bit more complicated of a formula, but give you that nice quick look and be something you might put together in terms of a practice problem or something like that. So let's go down here. We got the practice tab. That's going to be in blue, areas pre-formatted, so you can populate the blue areas with less formatting, working through the practice problem thusly. We're then going to go to the blank tab. This is where we're going to be constructing here. Last time we created our standard amortization table. Then we put together our ARM here. This is where we stopped with the construction of this table, meaning we've got the index rates. Remember, the index rates represent an index that's going to be the basis on which the rates we will be charged will be based on. Our margin is 2%. Therefore, we have a difference of, in essence, 2% between the index and the margin. We have no caps, so we got that nice even comparison, the 2% difference along the way. We calculated the first payment for the first year, and now we're going to be looking at the ending balances, which will be needed to calculate the adjustment. So in other words, in year 2 now, the rate is going to be increased to 12%. Now remember, when you're looking at these indexed or rates here, you can think of them 2 ways. One, you could think of them as we're projecting out what the rates will be in the future. That's how I would prefer to kind of look at it, and then thinking about our rate connected to it. Or you could think about it after time has passed. We know what the index rate is, and then what the payments would been at that point in time. Obviously, when you're thinking about an ARM, you want to do some projections out in the future. These are the kind of things you do not know, so you'll have to kind of make some estimates about them. Okay, so to do this, we're going to make our amortization schedule on the right. For that, let's try to copy the template we made over here and see if we can tweak it for our amortization table. So I'm going to put my cursor on column C, drag on over to column I, let go, Control C, or right click and copy. Bring that on over to column T and paste it there, right click and paste, or just Control V, paste it on down. Now we're going to have to adjust some of the information in this table because it's going to, any absolute reference is going to be referencing to the prior data set. So I'm going to be double clicking on the payment here, and you can see it's absolute referenced and it's referencing the prior data set. So I'm going to double click on it. Let's change this payment to be equal to the payment amount we calculated here, the 733 for year 1. I'm going to select F4 on the keyboard, making it absolute so we can copy it on down, and then enter. Now this one I'm going to copy all the way down first off, and then we're going to have to make changes year by year because that's when our updated rates are. So I'm going to double click on the fill handle. That'll copy it all the way down, and then we need to adjust our interest payments, and we need to adjust the loan balance here. So the loan balance is going to be equal to the 100,000. I'll pick it up from the table. That's our starting point. The interest then, double clicking the interest, you can see this absolute reference cell right there. So it's taking the 100,000 times the old interest rate. I'm going to delete that interest rate and pick up the rate of the 8%, which only applies to this year. But again, we're going to apply it out the whole way this time. F4 on the keyboard, $ before the P and 3, divided by 12. So enter there. Gonna double click and copy that down. Now this will be our starting point, and then I'm gonna make my last cell here should be equal to the 100,000 minus the 67. And then notice what it's trying to do. It tried to apply that even upwards. So you can undo that last calculation and it should take you back to where you were before. I want to copy it just down. The reason it does that is because it's a table and it's trying to apply it out to the whole column of the table. So if we didn't have a table, it probably wouldn't have tried to guess the next thing you want it to do. So in any case, we have this laid out. Here's our amortization table, standard table, as if the 8% was for the entire year and our payment was then calculated to be the entire period, the entire life, 360, and the payment calculated to be 733.76. Let's first check that that is in balance, that we're down to 0 at the bottom. So it looks like it has calculated correctly. There's our double check figure there. So now let's say, okay, what happens in year 2? If I'm going to highlight year 2 and make it a different color because we're going to have a different rate for year 2. I'm going to right click on it and then let's make that light green. So you can see at the end of year 1, we have an ending balance of the 99165 about. So we could do it this way, right? I'm going to say this is going to be equal to the amount from the table, which is the 99165. So there we have it. Now that might be a little bit different. Notice if you take it from the table, it'll be more exact because it could have pennies on it. So it's 99164.64 about. I'll keep it at the 99165. So that's one way we can get these ending balances, which again, I think it's a little bit more intuitive. We'll do another calculation as well so you can try to get it just in this table in a following presentation. And then the payment, we can now calculate again. We could copy the prior formula down, but what I'm going to do here is try to calculate it again so we can get an idea of how this formula works. So I'm going to say equals, let's say negative PMT shift 9. The rate, we're going to pick up the 12% now. The rate for year 2, I'm going to divide that by 12 because that's the yearly rate. We want the monthly rate, comma, number of periods. Here's the tricky part. I'm going to put brackets around this, and we're going to say a little bit different here. We're going to say it was 30 years. We'll start off with the years and then multiply it times 12. But then one year has passed. So I'm going to calculate the 1 year has passed by saying minus the 2 in this column plus 1, which is in essence minus 1, right? And so that would be 29 years. And the reason we're going to do that is so we can copy it down. I won't put the absolute references in this time. We'll calculate it normally, and then I'll go back in and put the absolutes in, and we'll copy it down. Then I'm going to multiply that times 12 because that's the number of years. 29 times 12 would give us the number of periods. So that's the periods. The present value then, comma, present value is going to be our last balance. So where we ended off last time. Enter. It's going to close up the brackets for me, so I'm going to say OK. And that gives us our 1,023.73. So 1,023.73, that's going to be our payment for year 2. So what I'm going to do is just go down into the amortization table and adjust that as we go and just see what happens to the amortization table. So what I'm going to do is say this equals this item, the payment up above, and instead of making it absolute, well, I could make it absolute. I could say F4 on the keyboard and enter. Now this rate is only going to apply for year 2, so we could kind of copy it down for year 2, but we're going to copy it down to the whole table as would be the assumption if we were moving as we go, meaning if year 2 happened and we don't know what's going to happen in year 3, we would apply this all the way down in the amortization table. We also need to change the rate to be the 12% now. So this one, I'm going to double click on this one. This rate here, I'm going to delete that and put in the 12%, select F4 on the keyboard, $ before the P and 4, and then enter. And that one, I'm going to double click all the way down again. It would only apply to year 2, but we wouldn't know that when the year 2 happens. So I'm going to apply all the way down. Then if this was done correctly in the amortization table, we can kind of have that double check figure down here because it should get back to 0 at the end, which it does. So it looks like that's been applied out properly. We can also then look at the end of year 2. We're at the 98,758. that's going to be our ending balance right here. So I'm going to say this equals then the 98,758, which that's rounded. So if I added some pennies, there'd be pennies to it, but I'm going to keep that there. That's why I'm using a reference. Let's do our payment calculation again. Equals, I'll say negative PMT shift 9. The rate is now going to be the 15% divided by 12, comma, here's the funny new part, brackets. We're going to say the 30 years, think about it in years, 30 years minus the 3, because we're in year 3, plus 1, which is minus 2 in essence. So 30 minus 2, 28 years, brackets. And then we're going to multiply that. Then we're going to take that and multiply it times 12 to give us the number of periods. And then comma. And the present value is the prior balance we had before this, which was right there. Enter. It's going to close up the brackets, and there's the 125377. So that's going to be in year 3 now. So year 3, going to go down, going to make this whole thing non-green, bring it back to the non-green. Let's say no green here. And then year 4, I'll just make that green already so we could see where that differentiation is, making that green. So there we have it. So year 3 is not green. So I'm going to have the new payment happen in here in year 3, which is going to be that 125377. Going to make that absolute, selecting F4 on the keyboard, $ before the Q and the 5. And then I'm going to copy that all the way down, even though it's only going to apply to year 3, because again, we wouldn't really know that as time passed, and we could double check our amortization table as we go that way. Then I'm going to double click on the interest, and we're going to delete the interest here, and we're going to say the new interest rate is now 15%. F4 on the keyboard, $ before the P and 5, enter. Putting our cursor back on that, double click in the fill handle, and that should go all the way down once again. And now if we go all the way down to the bottom, double check our number at the bottom. Does it go back to 0? Because that would indicate that we did stuff correctly. It does, so that's a good indication that we haven't messed up. At least, you know, that's good. So then I could say this equals our ending balance as of year 3. Ending balance as of year 3 would then be that number. And we will do this with a calculation for this balance. We could calculate the balance, but again, I think this is more intuitive. Let's do the payment again. Equal PMT shift 9. And then we're going to take the rate. The rate now is 17%. Let's make this negative PMT. Negative PMT rate, 17% divided by 12, comma, number of periods, brackets, taking the years first, which is that 30 minus the 4 that's there because we're in year 4 plus 1. So it's really 30 minus 3, closing the brackets, multiplying times 12 to get the month's amount, comma. The present value then is going to be the amount right above here, which is the balance, the last balance we just calculated, which you can't see, but it's right there. It's right there. It's closing the brackets up for me. 1,410, 1,410. That's what happens in year 4. So let's go down to year 4, changing this one up. We're going to say this equals our new payment amount. The new payment is the 1,410.34, making that absolute $ before the Q and 6 by selecting F4 on the keyboard, putting our cursor back on it. Even though this is only happening for year 4, we're going to take it the whole way down. Adjusting the interest rate now. This interest rate needs to be adjusted for year 4. Let's make that the new rate, which is now 17%. 17%. And then we're going to say F4 on the keyboard, $ before the P and the 6, and enter. Putting our cursor back on that and selecting that all the way down. Let's go back on down to period 30, see if we are indeed back to 0 at the end of this thing. We are. That's an indication that we haven't messed things up too badly. It seems like it's right. Seems right. So then we're going to say, let's say the ending balance after year 4 then is going to be that 98,335 as it's indicated on the, was that right? Actually, I need one more green. That's not quite right. One more greenie. One more greenie. Don't be a meanie. You got to have all the greenies on the year. Note 11. It's not an 11 year. There it is. So there's the 98,318, which is an estimate. There are pennies involved because if we add pennies, it's rounded. All right. Let's do the payment calculation one more time. Enjoy it because this is the last time we get to do it. PMT shift 9. The rate is now 12%. It went down this time, divided by 12 to get the monthly rate, comma, brackets. We've taken the periods, which is 30 years, minus the years we are on, which is 5, plus 1, which would be 4. So 30 minus 4. Closing the brackets, multiplying times 12 to get the monthly amount of months, then comma, the present value is going to be the prior balance, and enter. Closing the brackets, there it is, 1,029.34. Let's bring it on down to year 5. Bring it on down to year 5 here. And so we're going to be down here. Let's make the year 6 green so that we know where we're at. I want to know where I'm at. I need to know where I'm at. This is where I'm at right there. Year 5. That's where I'm at. That's where I'm at. So this is going to be then the payment amount of the 1,029.34. Making that F4, selecting F4 on the keyboard, $ before the Q and 12. Copying that all the way down. Double clicking on the fill handle to do so. And then we're going to adjust or take out this last interest rate one and change that to the new rate, 12%. 12%. F4 on the keyboard, $ before the P and 7. Enter, putting our cursor back on it, double clicking on Phil's handle. And then we'll go all the way down, see if that takes us back to 0 at the end of this thing. And so it sure does. It sure does. So that's an indication that we're doing that right. So that's good. So then note that we'll do this again, these ending balances, with basically a calculation, and then we'll take a look at our IRR kind of calculations. But before I do, note that if I delete these 3, we could copy it down. Copying it down is a little bit tricky given the fact that these ending balances are based on these payment changes. So you got to be it's a little tricky that way, but it should work here. So if I was to double click on this, remember this first payment was the 8 divided by 12, and then we took the brackets of L5 and we made that absolute because that's 30 over here. We put a $ before the L and 5 so that when I copy that one down, because it's outside of our data set, or it's in our data set, not in our table, we don't want it to move down. Then we subtracted out the 1 plus 1 times 12, and then comma, we then took the prior balance up top. All the rest we want to move down as we copy down. And then we should just be able to take that, grab Phil's handle, and pull Phil's handle down to year 5, and it should populate for us. So there we have it. So we'll start it there, and you can get an idea, hopefully, here from the amortization table, how this kind of works, because the amortizations table just still in balance, as we go. So it all kind of works out. As long as we don't have anything funny happening, we'll get into caps and whatnot later. But if you wanted to work it out in a nice quick table like this, I always think it's good to verify with an amortization table. But to get a good quick idea of it, you can then calculate the ending balances kind of as you go. And we'll also calculate basically our cash flow. We'll do that in future presentations. So we'll rework this. We'll do our cash flow calculations. And then we'll think about the internal rate of return type of information.